Thank you. Thank you, sir.
Okay, we come to the last speaker, the invited speaker, Associate Professor Dr. AHMAD SAFUAN RASHID from School of Civil Engineering, UTHM. He will talking about an overview of groundwater application, a bit different from rainwater harvesting. This is the invited speaker from UTHM. A bit of background, he's graduated from civil engineering from UTHM and also masters from UTHM and PhD in geotechnical engineering from University of Sheffield, United Kingdom. Without further ado, I would like to invite Associate Professor Dr. AHMAD SAFUAN. Please, welcome.
Okay, Assalamualaikum warahmatullahi wabarakatuh. And thanks, Dr. Mat Saidin, for introducing me. Okay, I would like to thank to the organizer for inviting me and give me a chance to share the current research under what we call as a geotropic, which is a center of excellence. And also I would like to thanks to all the participants, okay, in providing your times, okay. Definitely, my topic is far from the discussion on the rainwater harvesting, but it's still related, okay. When all the rain, and then we infiltrate inside the water, inside the land, and then definitely there will be a huge reservoir which is could cater all this to store all this water. Okay, so we need to understand on the what will be the benefits if we understand on the groundwater. Okay. So I will introduce a little bit on what is the groundwater itself. Okay, and then I would like to share some of the experience where we have conducted several studies on the groundwater explorations, okay, under geotropics, and then I will come up with the conclusions. Okay, when we discuss on the groundwater or surface water or rainwater harvesting, okay, we will discuss on the water demands. Okay, when we look on the National Water Resources Study, okay, majority of the total water demands, which is to comply on the use of the domestic, industrial, and irrigations, okay, are supplied by the surface water sources. Okay, so based on the charts that I share here, okay, there will be a huge difference starting from 1998 towards 2015, which is where we on the 1998 we are focusing more on the agriculture, and then towards the 2015, okay, we will change to the industrial country. Okay, so the total demand is predicted to increase by 60% from 30,000 million liter per day, okay, in 2020 to 40,000 million liter day in 2015. Okay, it's very huge demands that need to be supplied in order to cater for all these domestic industry and irrigations industry. Okay, so for example, for the Peninsula Malaysia, okay, to comply future potable irrigation water demands up to 2015, okay, the National Water Resources Study has recommended the construction of more water reservoirs. Okay, when we discuss on the water reservoirs, okay, definitely we need to construct dams, okay, or we can use the application of the groundwater. Okay. The application of groundwater can be an important supplementary resources for isolated rural area that are not served by the national water supply networks and for emergency use. What does it mean with the emergency use? For example, when we want to during the pit burning problems, okay, so we may use all these resources to overcome the pit burning problems. Okay, for the domestic water supply, okay, only 1.3%, which is around 247 million litre day of the present water use in Malaysia is from the groundwater resources, whereby 80.5% from the rivers and 18.2% from the dam sources. Okay, means that the use of the groundwater is still small amount as compared to the other sources. So, but the usage of the groundwater is it keep increasing. Okay, which is from 2008 to 2018. Okay, they up to 26% of increasing. Okay, this is the scenario in Malaysia where where in Kelantan, okay, is among the state that use the groundwater as the public water supply, okay, and followed by Sabah and some states like Pahang and Perlis. Okay, so as we can see in this slide, okay, whereas in Malaysia we only use about 2% or utilize 2% from our total groundwater. However, in other countries, for example, like Denmark, okay, Austria, Thailand, China, and USA, they have utilized up to more than 50%, okay, from their groundwater supply. Okay, so we have this opportunity, okay, if we can make use the source of the groundwater, so that we can increase the utilization number. Okay, based on the GMG report, Jabatan Mineral and Geoscience in 2019, okay, so they has listed some of the reason why lack of groundwater developments. Okay, for example, failure to recognize the potential of groundwater resources, lack of full assessment of the resource in the country, misconception that groundwater exploration is not suitable, okay, fragmented policy, legal and institutional framework to ensure the resources is manageable sustainably. Okay, the diagram show the water cycle, okay, where as we can see is the diagrams, okay, when we have a resource, when we have a source from the rainfall and also the surface water, okay, so the infiltration will be begin, okay, and it will start to enter the fractural the unsaturated layer and downwards to the aquifer and the fractural rock aquifer layer. So groundwater is the water present beneath Earth's surface in soil pores space and in the fracture of the rock formations. So we have two types of groundwater resources. Okay, first from the shallow part and another one from the deep aquifer parts. Okay, so when we try to get the supply from the fractural from the rock, the deep aquifer layer, so we can get a lot. We can have more what we call as more clean water quality. Okay, when we look on these diagrams or this chart, okay, in terms of the number of the storage, okay, reported by Japanese International Cooperation Agency, JICA, and also the National Water Resources. The total number of the groundwater storage is about 5,000 billion meter cubes, or equal to 5 trillion meter cubes. Okay. So yeah, we still have a lot of resources to be used. Okay. Then currently there are a lot of effort has been done, okay, especially by the JMG, okay, and also the academicians, and also the GLC, okay, in order to make use of this the groundwater resource. Okay, for example, on the maps on the left side, okay, this is the number of the tube wells. Okay, it's been reported more almost around 5,000. Okay, wells has been dig and built. Okay, to obtain the groundwater from approximately from each state in Malaysia. Okay, and on the right side is the number of wells that's been built. Okay, to cater for the problems, especially if there are pit burning problems. Okay, in the pit area. Okay, so a lot of effort has been done. Okay. By the Department of Mineral and Geoscience, JMG, Public Work Department, JKR, and also a lot of initiative has been done by the university, okay, government-linked company, and also the private sectors. Okay, so this is some of comparison, okay, between the surface water, normally from the river, okay, shallow groundwater, which is above the rock layer, okay, and the last one is the deep aquifer. Okay, so when we look on the for example on the mineral contents, okay, the deep aquifer could provide a very high mineral contents. Okay, and also when as a background of geotechnical engineer, okay, so when we look on the, for example, on the settlement problems, okay, I guess by obtaining the water from the deep aquifer will be less influence in terms of the problems with the settlement compared to the shallow groundwater. Okay, so we need to differentiate between the risk when we try to obtain the water from the shallow groundwater, which is potential to have settlement problems. Okay, which is the ground start to settle. Okay, and compare if we have if we do explorations on the deep aquifer, where the problems related to the soil settlement or ground settlement is very minimum due to the due to the formation of this aquifer or rock formation is very strong. Okay. Okay. We have carry out several groundwater study, okay, under the geotropic. Okay, I would like to explain a little bit on the geotropic. Okay, geotropic is what we call as a center of excellence. Okay, which is started in 2016. Okay, we are more cater the problem which is related to geology, geotechnics. Okay, and for today, I would like to discuss on the current research that has been conducted on the ground water explorations. Okay, so this is the flow charts that normally introduced when we want to carry out for the groundwater explorations. Okay, so at the first stage, okay, field explorations. Okay, we need to get the informations on the secondary data collections. Okay, then during the field explorations, okay, so we need to collect all the primary data collections, where we need to know what will be the geological formations, okay, the geology characteristics, and also we need to identify the coordinates or the locations. Okay, so during the field work, there will be several fieldwork studies will be conducted. Okay, for example, the weathering profile. Okay, and then we conduct for the geophysics study to look on the subsurface formations. Okay, so once we have identified where will be the locations of the groundwater reservoir, then the stage 3 will be conducted. Okay, where exploratory drilling will be conducted to by using the tube well drilling, and then to get the groundwater. Okay, so this is the more detailed explanations on the type of the experiment or study for each criteria. Okay, for example, for the geological study, okay, we may look on the type of the rock, okay, which is weathering, discontinuity, geological structure, the topography, and the drainage. Okay, and to obtain all this data, probably we need to conduct for the borehole. Okay, dig a borehole and then extrude all the samples and then identify the type of the geological characteristic. Okay, in order to verify the geological characteristic, okay, we conduct the geophysical study. Okay, either using seismic or resistivity. Then, in addition, need to conduct for the hydrogeological study. Okay, to determine the porosity, permeability. Then include with the geohydraulic study, okay, to identify the groundwater quality. Okay, the quality assessment for drinking water, so need to comply with the Malaysian standard. Okay, in order to be used directly. Okay, so determine of the hydraulic parameter. Okay, which is to make sure that the recharge rate is high. Okay, once we have explored the area. Okay, and also the groundwater and quality in a rock aquifer. Okay, this is the list of the project that's been successful carried out under the geotropic SAF. Okay, so most of the study or most of the projects been conducted in Johor area. Okay, which is under Iskandar Puteri, Sedenak, and UTHM itself. Okay, this is the part of the geological and geophysical survey. Okay, where we identify the profile or the rock formations, okay, underneath the area. Okay, this is an example of the result. Okay, when we use the geophysics methods. Okay, where we can identify what we call as the rock or the ground formations, and as a comparison, we need to compare the result with the what we call as with the borehole result. Okay, to make sure that it is similar with what we interpret from the geophysics methods. Okay, this is an example for the obtained subsurface profile. Okay, at the site where we need to bore up to 28 meters. Okay, where with a different type of soil formations. Okay, then when we have identified the area which is have a potential huge reservoir area, so the drilling process will be started. At the same time, we need to identify the locations, okay, of the area, and then do a mapping, okay. Okay, this is example of the volcanic rock aquifer breakthrough, okay, where I'm not pretty sure in terms of how many liter that's been obtained per minute, okay, but it can directly be used or be drinks, okay, from the source. Okay, this is a part of the exploration in UTM. Okay, this be conducted recently. Okay, and for the conclusion part, I just put two items. Okay, which is we should recognize the groundwater resources. Okay, and should be an additional resource for balance the water demand supply in Malaysia. Okay. And the last thing, we should integrate, okay, the source from the groundwater and the source from the surface to provide efficient and holistic for the Malaysia water demand supply. Okay. So I guess with that, I end my presentations, okay, and I will try my best to answer all the questions. Basically, my background is geotechnical engineer. But if the question related to geological, so we may keep in touch later on. Okay, thanks, Mr. Chairman.
Thank you, Dr. Ahmad SAFUAN, for your interesting overview about the groundwater application in Malaysia. So I open if any question from the participant.
Okay, allow me to ask one
Yes, Prof,
question.
please.
Doctor, interesting presentation. You mentioned that the total groundwater resource in Malaysia is approximately 5 trillion cubic meters.
Yes,
but I would believe that this include all over Malaysia Peninsula and also Sabah, Sarawak.
Yes,
but based on my experience also, I noticed that if we dig deep in coastal areas, we are bound to hit groundwater with high salinity, sodium chloride. Yes. So how would you recommend we manage high salinity groundwater? Thank you.
Okay, thank you for your very brilliant question. Okay, sorry, I need to share my slide as well. Okay. So, so on the salinity problems, okay. So actually, when we dig more deeper, okay, it's been reported that the level of salinity will be reduced. Okay, so because in terms of filtering process from the rock itself, it contributes to reduce the value of the salinity. So that's why we need to differentiate between the shallow groundwater and the deep aquifer approach. So that's my very brief answer for your question, Prof.
Okay, right. The one that we did was I think it's already about 100 meters. So
okay, Prof.
I would consider that it's quite deep. Huh?
okay. In that sense, I consider it's very deep. Okay. Yeah. In future, the Geotropic will join a research with what we call as with membrane research groups, which is MTech in UTM. So they will provide the filter by using the membrane. So I guess that's the other way to reduce the salinity problems.
Okay, right. Thank you.
Okay.
Okay, thank you. I open one more question if any from the participant today.
Assalamualaikum, Dr. Safwan.
Salam.
Okay, Dr. Azra, please.
Probably I have two simple question here.
Okay.
My first question could be relate with Prof. Tamizi just now.
Okay.
If Prof asked about salinity, I also have a concern about the electrical conductivity and also total dissolved solid.
Sorry.
If I have a concern with electrical conductivity and total dissolved solid in terms of the quality of the groundwater. So when you talk about the minerals, because we know that the groundwater attached to the rocks, so many for ages, so it should be high in TDS and also electrical conductivity, right? So how do you overcome it? And also another thing is from if you have any data and you don't mind to share with us about how fast the groundwater normally takes for the replenishment. I mean, we often use groundwater without knowing how long it takes to replenish again, because you cannot use groundwater continuously, right? So this happens sometimes in rural area, like they rely too much on the groundwater without knowing that how long it will take again to replenish to get the water come back and then can use again. Okay, thank you.
Okay, thanks, Dr. Azra. I guess for the first questions, honestly, I couldn't answer the question, okay, because it's more related to the chemistry. Is it correct? The quality of the water, because actually my background is not on the water quality. Okay. But I will try to get the answer, okay, and try to discuss with my teams, okay.
Okay, thank you.
Okay. So the second questions, as far as concerned, okay, when they carry out for the resistivity test, okay, so we try to get the best huge reservoir underneath the groundwater, underneath the ground, okay. So from their estimation or calculations, they consider that is the water supply will be could be extend for a long period of times, okay. So we need to consider in terms of the total cost of the project, okay, what will be the benefits towards when after we do the drilling process, okay. So and again, I didn't have good explanations in terms how to calculate what would be the total of the reservoir underneath the ground.
Oh, that's fine.
Okay. Yeah. Sorry about that.
It's okay.
Okay.
Can I just add on that discussion by Dr. Azra? The practice in US, US is that when in 50% of US citizens use groundwater, and what they did is that their wastewater, domestic wastewater, must be treated at high, at their standards, and then they would pump back what we call recharge into the groundwater. That is how they maintain that is how people in US do it. Right.
Okay,
thank you.
Yeah, thank you, Prof.
Okay, thank you, Prof.
Okay, thank you to the participant who participate in this session, and on behalf of the committee, I would like to thanks to Dr. AHMAD for your very interesting topics and knowledge sharing on the groundwater application in Malaysia. So I think we almost end. Again, for this morning session, we have almost more than 100 participants, involved in this session. And we also appreciate the keynotes, Engineer Muhammad Zaki, Dr. Ahmed, Darwan, Ms. Fadila Jasmine, Ms. Wan Chapons, and last speaker, Dr. Ahmad SAFUAN, for your time and contribution to this seminar session.